Good day, everyone. I'm Abdullah Umar Abdullah. I'm presenting the topic Pearson's, Kendall's, and Spearman's rank correlation. Is any of them robust to ecological fallacy of quantitative traits? A test on association of air height with external content. Planetary which are studied quantitatively are known as quantitative traits. They include the air height and the canthal length. Galton's study on children and parents' mid-age association led to the concept of correlation and discovery of regression. Carl Pearson formulated its mathematical definition years later. Pearson correlation is a measure of linear association and it ranges from -1 through 0 to +1. However, it is badly affected by outliers. An outlier is any observation that differs significantly from the other observations. To solve the outlier problem and to be able to make analysis of non-parametric or analysis of non-parametric with parametric variables, two other statistical association tests were invented in form of Spearman's rank and Kendall's tool. The outlier problem had been solved by these two inventions. However, Pearson's correlation is still tempered or affected by another factor called ecological fallacy. An ecological fallacy is a formal fallacy in the interpretation of statistical data that occurs when inferences about the nature of individuals are deduced from inferences about the group to the individual are derived. Here on this paper, we try to analyze the ecological fallacy within a group and to see whether any of the three association tests is robust to ecological fallacy. To do that, we group the data into 5 based on proportionality around the mode. From much less than mode, slightly less than mode, exactly equal to mode, slightly greater than mode, and much greater than mode. And finally, we will briefly suggest a better association analysis technique that will be robust to both outliers and ecological fallacy and will hence be called the coefficient of predictability. Proportion and variation are the backbone of many scientific theories and mathematical equations. In mathematics, an entity can vary or be proportional with one another or more entities in same or opposite direction. Proportion and variation are majorly divided into 4. Using Banya Khalifa, both the ear height and the canthal length were measured. However, the ear exists in pairs, and in the ear show asymmetry, and both the ear and the canthal length exhibit what is called sexual dimorphism. However, no emphasis or attention was laid to either the asymmetry of the ear or the sexual dimorphism exhibited by both of them. However, for the ear height, the arithmetic mean is used as the ear height. Both the ratio and the inverse proportions of EC and EH will be calculated, and the ratio and product of mod EH with mod EC will be the population constant. Mathematically, we can put everything in form of equation. That if the ear height is directly proportional with EC, then EH is equal to K1 times EC. And if the ear height is inversely proportional with EH with EC, then EH is equal to K2 over EC. All the two can be combined in a single quadratic equation as presented here. In reality, any two variables, say EH and EC, can be in direct or inverse relationship with each other. However, they can also be in neither. Thus, making the association of variable with any number of variables take the shape of 3 power n minus 1 combination. To put it simple, if we have two variables, let's say A and B, there is a possibility that A is directly proportional with B, and there is a possibility that A is inversely proportional with B. And then there is another possibility that both A and B are not related whatsoever. And now suppose we have another variable C. So now that we have variable A, which is in relationship with two variables B and C. First of all, there is a possibility that A is in direct relationship with both B and C. And there is a possibility that A is in inverse relationship with both B and C. Now we have two possibilities. There is a possibility that A is in direct relationship with B and in inverse with C, or the reciprocal. Now we have four. And there is a possibility that A is directly proportional with B, or it is inversely proportional with B. And the possibility that A is directly proportional with C or inversely proportional with C. Now we have total of 8. But there is a possibility that A is in no relationship with any of them. That's the last one. So when we take 3 power 2, making 9, when we factor the last one, 1, a possibility of disassociation, then we will now be left with 8. And in the same way, no matter the number of variable, it will always have the shape of 3 power n minus 1 possibilities. Where n is the number of independent variables. One is the situation where the independent variable is not in association or visible association with the independent variables. Grouping. These are the 3 groups with the data which all analysis will be taken into consideration. First of all, much less than mod, which is less than mod minus 5%, approximately equal to mod, and then and then finally much greater than mod. And sometimes the grouping will be made into 5. Much less than mod, slightly less than mod, exactly equal to mod, slightly greater than mod, and much greater than mod. Taking the Punnett square of the two, both EC and EH will be left with 9 groupings. And when we take the 5 groups and take the Punnett square of them, we will be left with 25 different groups. A result shows the mod EC and the mod EH to be 90 and 60 millimeters respectively. Distribution of EH and EC around mod, one group into 3. Around mod, one group into 5. We have exactly 24 people, 24 subjects have exactly mod ear height, and then another 37 have exactly mod EC. When we take the Punnett square of EC and EH, we'll find out that 138 subjects have approximately both mod EC and mod EH. But when we make it into 5, we'll find out that only 3 soldiers have exactly mod EC and mod EH. Here we take the direct proportion and the inverse proportion, and we group the data into 5, with the mod being the center. Those that are in the proportion of since the mod EC we found to be 90 and the mod AH is found to be 1.5. So those subjects that have exactly 1.5 ratio are presented here, and those that have slightly less than 1.5, and those that have much less than 1.5. And here, those that have slightly greater than 1.5 and much greater than 1.5. And this one is the frequency based on the inverse proportionality. Since the product of mod EC and mod EH is 5,400. I have slightly less than that as 76, and we have 127 that have much less than that. And here we have 81 having slightly greater than that, and then one 108 having much greater than that. When we take the proportion and the inverse proportion, we'll go down into 3. You'll find out that 67 subjects have exactly, approximately, mod direct proportion and approximately mod inverse proportion. However, 160 subjects have their inverse relationship approximately equal to mod, and the 147 have the direct relationship that is approximately equal to mod. When we put it in form of equation, K1 will be equals to 0.66667, and then K2 will be equals to 5,400. This table shows the correlation of the aggregated data, and the Pearson correlation is 0.222, and the Kendall's is 0.159, Spearman's 0.221 at level of less than 0.01 significance. However, when we take the correlation analysis of the group data, first of all, we take that of the direct proportionality, and we found out all the proportions were positive, and they are much more than the correlation coefficient of the aggregated data in all cases. Here the data were grouped into 5, but both based on inverse proportionality. Look at it, all the 3 association analysis yielded negative coefficient, with maximum being -1 in all cases. And for most part of it, the correlation coefficient was at least greater than the aggregated, except for -0.180 here, and then the -0.219. While of 24 subjects have exactly mod AH and 37 have exactly mod AC, only 3 subjects have both mod AC and AH. Simultaneous distribution of both ratio and product of EC and AH are presented in table 12. The ratio of EC and AH of 1.7 solid is in the ±5% range, and then and the product of EC and AH of 160 subject is within the ±5% range of the product of the mod AC and mod AH. However, 7 subjects have both ratio and product within ±5% range, meaning the intersection of direct proportion and the inverse proportion of AC with EH is 67. Only 67 from both DP and IP will give 80 and 93 for DP and IP respectively. Collectively, the EC and EH of 240 subjects are either directly or inversely proportional with each other or both. Thus, the union of direct and inverse proportionality of AH with EC is 240. Meaning, we can accurately predict, at least within the error level, predict 240 year height of the population from the value of the AC, and the vice versa. So meaning, if we take this as a coefficient of predictability, since up to 240 subject year height can be predicted by the union of the 2 relationship or the 2 equations that we put it. When the coefficient of predictability or the coefficient of predictability 5 is equal to 240 over 395. And 240 over 395 is 0.608. Meaning 240 EH and the AC of subject can be predicted by union of the direct and inverse proportionality equations of EH and AC with EC at maximum error of plus or minus 5% between the measured EH and the equation derived EH. At level of plus or minus 5% error, predictability of EH by EC is 0.3722, and taking the inverse equation, it will give 0.4051. However, the 7 subject probably within both range. The intersection is 0.1696. Thus, by definition, the coefficient of predictability / prediction phi is defined as the linear number of proportions of dependent variables with 3 power n minus 1 permutation of n combination of independent variables that fall within the specified range / limit of proportion of both mod dependent variable with 3 power n minus 1 permutation of mod n combination of independent variable divided by the total number of dependent variable, and it is summarized in form of equation here. In terms of equation, however, coefficient of predictability / prediction phi is the union number of accurately predicted dependent variable by 3 power n minus 1 equations of a dependent variable with 3 power n minus 1 permutation of n combination of independent variable within the limit of specified level of error divided by the total number of the dependent variable. Conclusion, neither of the three association tests is robust to ecological fallacy. The coefficient of predictability is not only robust to the aforementioned, but also informative about the population distribution, sequences, and proportions, and also give the probability of prediction, percentage, and accuracy of a prediction, among others. While Kendall, Stowe, and Spearman are improvement over Pearson's, the need for robust parametric association tests that is robust to outliers and interpopulation ecological fallacy is eminent. We can see here, despite the fluctuation of air height and the fluctuation of AC, we can still predict up to 240 out of 395 from each other, given the coefficient of co-predictability at 0.608. In contrast to the normal association techniques, which will have the correlation coefficient as 0.222, when we even consider the Pearson's correlation, with even the remaining one being less than that, which means both of them are affected by it. All the association techniques currently in use are affected by ecological fallacy. Neither of them or none is robust to ecological fallacy, and thus we think we want to suggest the shift or use of coefficient of predictability. You can either go with it in form of proportionality, or you can go with it by deriving equations and compare the level of agreement. Here I'm comparing the agreement. Here we choose the level of agreement at plus or minus 5%, but it can be chosen at less than or more than that. Similarly, we use the mod value at the constant, but one can use the mean or the median or any defined specified value. With this, we come to the end of this presentation. Here are the references. Thank you for listening.